In this lesson, we are going to talk about inverse functions. Our objective of this lesson is to determine if a function is invertible for ordered pairs and graphs. In the next lesson, we will talk about finding the inverse of a function. To understand inverse functions, first we need to talk about what a function is. A function is defined as something that has, for each x value, there is exactly one y. So for every x value we have, there's exactly one y. When we're talking about a set of coordinates, we're looking for no repeating x values. When we look at a graph of a function, we're looking for that graph to pass something called the vertical line test. The vertical line test tells us if I draw a vertical line straight up and down through a graph, it should only hit that graph once every time I draw that line. If it even hits it twice, it becomes not a function. So what is an inverse function, and how do we get them? An inverse function is when you switch the x and y's. Once you switch those, we have the inverted function, and we're looking for no repeating x values, and for it to pass the vertical line test if we're looking at a graph. The notation for function is f inverse of x. So we read this as f inverse of x. If I look at these tables to the left, right here to the right is f of x. We have a bunch of coordinate pairs. Every x value in this table has one y value, so we are able to invert it. To invert it, we are going to switch each x and y pair around. So x and y, we have -2, -3. So the y value is going to become the x, -3, and the x value is going to become the y, -2. For the second point, we have -1, -1. The y value will become the x, and the x value becomes the y. Again, for 0, 1, we're going to make the y value the x, so x is now 1, and the y is 0. And again, we can repeat it for the rest of the table. So how do we determine if a function is invertible? For a function to be invertible, it must keep the properties of a function in its original state and inverted state. So it must keep the properties of a function in its original state and inverted state. So again, an inverse is when we switch the x's and y's. With coordinates, we're simply changing the x's and y's around. If we're looking at a graph, we're actually going to rotate the graph 90 degrees, or turn the graph 90 degrees. So to check if a function is invertible without graphing or switching it, with coordinates, we are looking for only one x with only one y. So we shouldn't have repeating x's, and we shouldn't have repeating y's. If we're looking at a graph, we're looking for it to pass the vertical line test. And for it to pass the horizontal line test. Now the vertical line test shows the original as a function. And the horizontal line test shows that the inverse is a function. So now that we have some notes, let's go ahead and look at some examples. So our first example is f is the set of points 2, 4, negative 2, 4, and 3, 9. So you should realize in this set that 4 repeats. Since 4 repeats, we only want one y value. We have 2 here, so this function is not invertible. If we look at example 2, we have 3, 5, 7, 9, 10, 12. None of the x's repeat, and none of the y's repeat. Therefore, this function is invertible. So to invert this function, we would switch the x's and y's. So h inverse is going to equal the set of points 5, 3, 9, 7, and 12, 10. Example 3. Now we're looking at a graph. So remember, we have to go and look at the vertical line test and the horizontal line test. So if I pass vertical lines through this graph, no matter what, it's only going to hit it once. Same thing over here. If I pass vertical lines through the test, it's only going to hit one time. Now I need to test if the horizontal line test works. Since when I draw horizontal lines through that graph, it will only hit it once, then I know it's past the vertical and it's also past the horizontal, so it is invertible. Again, if I look at the next function here, if I pass horizontal line test through here, it's always going to hit it once. So again, this function is invertible as well. Now let's look at example 4. Example 4 passes the vertical line test, but as soon as I put a horizontal line through it, it hits twice. I hit the graph here, and then I hit the graph here again. Therefore, this function is not invertible. If I look at the second graph in example 4, passing vertical lines through it, it passes. Now, if I put horizontal lines through it, up here it only hits once. But if I put a horizontal line through here, I actually end up hitting that graph 3 times. Again, anytime it hits more than once, it becomes not invertible.